Welcome to this tutorial video. In this video we'll be looking at basic series and parallel circuits, features to identify them by, and some simple calculations for voltage and current. So what feature identifies a series circuit? Well, a series circuit has only one path, or if you like, a loop from the positive terminal of the battery through the components back to the negative components. Much like a hose, there is absolutely no branches going from one end of the battery to the other. And here it is as a typical circuit diagram, going from the positive terminal is the larger or the taller of the drawn terminals, and the negative is the smaller. So we analyze the current flowing from the positive terminal through the two light globes in this case and back to the negative terminal. One complete loop. That is a series circuit. What feature identifies a parallel circuit? Some of you might be able to see this straight away. A parallel circuit has two or more possible paths. So again, from the positive terminal, current travels along. It gets to this point, and there's one choice whereby it can flow through the first light globe in the first branch, or the current may choose to continue down and flow through the second light globe and return all the way back to the negative terminal. Let's go back to the circuit. Probably easier to see here with the schematic diagram. So from the positive terminal, the current flows, gets to this branch, and it can choose to go through the first branch, or the current can choose to travel through the second branch. Now in reality, some travels through the first branch and some travel through the second branch. Okay, then they combine and go back to the negative terminal. So here, anywhere with a branch or a node or a junction is a giveaway that we're looking at a parallel circuit. Let's consider what happens to the voltage within a series circuit. So the sum of the voltage drops, and what we mean by voltage drops, so here, drops across components. Voltage is never dropped or lost within the wire. We assume they're perfect, no resistance. It's a bit of an exaggeration, but we'll use that analogy for year 10, 11, and 12, that no voltage is lost in the wire. However, between point A and B, we've got a component, a light globe. So we say that there's a voltage drop between A to B, voltage drop between A to B, and on the other side, between point B and C, there's also a component, and therefore a voltage drop, voltage between B and C. So we're saying that whatever we lose in V or B, A and B, whatever we drop across A and B, plus whatever we drop across B and C, must be equal to what we started with. So the sum of the voltage drops, VA and VB, VA to B and VB to C, within the circuit is equal to the voltage of the battery or supply. V little s represents the supply or the battery voltage. Okay, so we can say that the supply voltage is equal to the individual drops within the circuit. Voltage between A and B plus voltage between B and C. Okay, the AB subscript represents voltage between points A and point B. So here's an example in our circuit. Calculate the voltage drops between point B and C, given that the supply voltage, or the battery, has 12 volts, and the voltage drop between point A and B is 6. So as always, let's write down what we know. The voltage between B and C is what we're trying to calculate, that's the unknown. The voltage of the supply, or the battery, is 12 volts. And the voltage between point A and B is 6. We know that these two voltage drops between AB and BC have to add up to equal the supply. So 12 that we started with equals 6 in the first light globe, plus whatever is left in the voltage between B and C, between point B and C. So this, we can see, has to be 6. 6 plus 6 will give us 12. So the voltage drop between point B and C is 6 volts. Consider the current. So what happens to the current within a series circuit? Well, quite simply, the current remains constant within the series circuit. So we have a current coming from the supply, from the positive terminal, and it remains the same at point A, point B, point C, all the way back. So if this was 10 amps coming out of the battery or the supply, we'd have 10 amps at point A, 10 amps going through this first light globe, 10 amps at point B, 10 amps through the second light globe, and 10 amps at point C. It's much like water traveling through a hose. If I have a resistance or a kink in the hose, it slows the water going into the hose into that kink and also the water out of that kink. Current is always the same in a series circuit. So the current from the supply or the battery is equal to the current of point A, current at point B, and current at point C. So when there's this one letter subscript, that represents the current at point A, at this exact point, not between A and B, but at point A. Current flows through a point, whereas voltage is found across or between 2 points. And of course, current travels from the positive terminal all the way around to the negative terminal of the battery. So an example here. Calculate the current at point A, point B, and point C, given that the battery or the supply has a current of 5 amps. So the supply current is 5 amps, current at point A is questioned, current at point B is questioned, and current at point C is questioned. But we just explained the current is the same everywhere in the circuit. So point A, B, and C is equal to the supply current, which is equal to 5 amps. Let's now consider parallel circuits. So what happens to the voltage within a parallel circuit? This is quite simple. The voltage across each branch, so between point AB and between point CD, is equal to the supply voltage or the voltage of the battery. And here it is written as an equation. So example here, let's calculate the voltage drop between point A and B, so voltage AB, and also the voltage between points C and D, voltage C and D, given that the supply voltage is 12 volts. Okay, so voltage between A and B is a question, voltage between C and D is a question, and supply voltage is 12. Now we just explained in the last slide that the voltage in an individual branch or between A and B will be equal to that between C and D, and they'll both be equal to the supply voltage. So here it is as an equation. So the voltage between A and B in the first branch is equal to the voltage between B and C, which is equal, both of them, to the supply voltage of 12 volts. So we have 12 volts here, 12 volts at this point, and 12 volts at that point. What happens to the current within a parallel circuit? Well, the sum of the current within a branch, within the branches, is equal to the current leaving the battery or the supply. So that says whatever current I have in branch A plus whatever current I have in branch B, when I add them together, that will give me the supply current. Here's our equation. Let's try this. So let's work out what is the supply current in this final example, IS, given that branch A has a current of 2 amps and branch B has a current of 3 amps. So current in branch A is 2, current in branch B is 3, current in the supply is question mark. We know the supply is the sum of these two branches. 2 plus 3 gives us 5 amps. So for this to be true, I must have had 5 amps coming from the battery. It comes to this branch, 2 amps is going in the first branch, and 3 amps is going in the second branch. Now, when they join back together again, we'll also have 5 amps returning back to the battery. Worth noting that in this example, these light globes must be different resistance. The one in branch A must be a slightly higher resistance, because less of the current of the 5 amps is travelling through it, being 2 amps, and a greater amount of the 5 amps, being 3 amps, is travelling through branch B, so there must be a slightly less resistance. Look, I hope this has explained the basics of identifying series and parallel circuits, also examining what happens with the current and the voltage in both circuits, and how to perform calculations. Remember, in a series circuit, the voltage breaks up and the current's the same. In a parallel circuit, it's the current that breaks up and the voltage in the branches are the same. The reverse statement in both scenarios. Thanks for watching. Study hard. Enjoy your physics.